Hey mathletes, so in this video we're going to look at rate of change. So rate of change is just like slope, but there's a unit rate. So it means it's a real world situation, so it has units. So in this situation here, we've got a table and a graph. They're the same function. So if we want to find the slope, again, we're looking at rise over run, change in y over change in x, or delta y, delta x. Delta just is the Greek letter D for difference. So over here, the independent variable is time in hours. Time is always independent. And the dependent variable is cost in dollars. So we're checking the difference, 145 minus 100. So it's increasing by 45 as the time increases by 1 hour. And we can see that in every single case, the difference in y is 45. So this is definitely linear, which is where this graph comes from. So the rate of change is going to be $45 for every 1 hour. $45 per hour. In the graph, we can see it here, because again, this coordinate is 1, 145. And this is 3, 235. If we made a slope triangle, the run is 2 hours, and the rise is $90. So the 90 over the 2 still gives us the $45 per hour. This means for every hour, the cost increases by $45. For this example, we have a graph. Time in years is the independent variable. Again, time is always independent. And this is the record of an obstacle course. So 2015, 2016 goes down, goes back up. The question is, what's the rate of change between 2015 and 2019? So we don't actually care what happens in 16, 17, or 18. We only care about these two endpoints, which means this is the line we really care about finding the slope and the rate of change to. So if we look at the slope triangle, it's increasing by 4 years, and the time goes from 22 up to 26 minutes, so 4 minutes. If we set up the slope formula, we've got 26 minus 22 over 2019 minus 2015. 4 minutes over 4 years is 1 minute per year. Again, this has a meaning. This means for every year, time has increased by 1 minute. So when faced with a word problem like this, we got to figure out what the independent and the dependent variables are. So our pipes are leaking, so we call the plumber. After 4 hours of work, she charged $285. So if we have time and money, time is always independent. So time is always the x. So this is a coordinate 4, 285. Then she came again to fix a leaky toilet. She charged $395 for 6 hours of work. So 6, comma, 395. So delta y, so our change in the y number, is from 285 to 395. That's plus 110. And that's dollars. Change in x, delta x, is from 4 to 6. That's plus 2. That's 2 hours. So 110 divided by 2 gives us $55 per hour. So this plumber makes $55 every hour.